Okay, Assalamualaikum warahmatullah. My name is Abdul Razak. So, welcome to thermal management topics. So, you will all be with me discuss regarding thermal management and consideration for electronics applications. So, I will divide my slide into a few parts. I will download accordingly. So, you all may view. You may pause, you may slow down, or you may fast forward as you like. Okay, this is my number. You can contact me through this number. And I'm staying here in block 2. Office hour only. Okay, as introduction, we already know that power electronics being applied since the earlier age, when power processor device or power processor is introduced to the market. So, but in the earlier stage, the device that being used in power electronics applications such as converters, power processors, rectifiers, their size are quite significant. That is the size or the device itself are able to dissipate the heat that being conducted or being processed inside the system. So we can see here the early days that the size of power semiconductor was quite large, and the cost itself at that time is quite high. And the concern on heat removal for the device itself is not so important, because the device itself can dissipate the heat to the environment or to the ambient. But when the time passed by, the device has been reduced significantly. You can read from this comparison of size. The device become very small, even though the capacity of the device is the same, which is it can conduct high current, but the device size is reduced to the SMD level, surface mount device type level. You can see the earlier stage, the size is quite high, quite big, it reduced to the fingertips of size. So as you all have learned inside other subject, that is when the current pass through a conductor, so it will emit some sort of energy and losses to the ambient. So in the current days, the device has been reproduced during surface mount technology, SMT. So we can see that there are numerous of IC manufacturers in the market. We can go up to hundreds of manufacturers, and they're producing the same device with the same part number, but different kind of characteristics. So we can see right now, if we Google from the website, so the device that came out from the search, we can see the size is quite small compared to the earlier stage or earlier age of the power electronic processor or power processor device. So we can see here, this is a small signal system transistor, which are used to conduct small amount of current in terms of milliamperes. It uses the same PN junction concept, which fabricated on the silicon based wafers. So here are the metal type kind of transistor. We can see here the small signal system transistor, they don't have any kind of metal tap. And this is the picture of GTO. And we have here Schottky, SCR, GTO, UJT, BJT. All of these are power processor device. What we mean by power processor is that the current that flows through the device is not in terms of milliamperes, but from amperes up to tens of amperes and up to hundreds of amperes. So when the higher current passes through the device, same like the current that passing through the wires, so there is losses which is what's so called increase when the value of current increase. So we can see that the equation of the losses inside the current is equal to P, which is equal to I square R. So the higher the current goes through the wires or the device, the higher the P will be emitted to the environment. So we can see here the device that used for power processing or to conduct high current values, they have some sort of metal tab with a hole here. So what the use or the application or the purpose of this hole? So in the current stage now, we have another structure which is thermal management, heatsink and heatsink or heat exchanger. So if we Google heatsink or heat exchanger from the website, you can see there are multi types of pattern or construction of this heat sink, and which is used to dissipate the heat from the power electronic device, transistor, BJT, GTO, all such power device. They will need some sort of external heatsink. You can see here in the earlier slide, this is the transistor module type, which is 3 or 2 transistor put in one package. But in the practical circuit, the transistor itself cannot work on its own, because what? The heat which we dissipate from the transistor is very hot and very high, so we need some sort of external heat exchanger to cater the heat. So you can see here, this is the transistor, 3 in pair. This is the heatsink, and so the heatsink size is much bigger than the transistor itself. And so we have multiple kind of heatsinks, depends on the application that we will discuss further. So this is a type of heat exchanger. Previously, we have 2 terms of heat sink mounting, which is common heat sink. Common means that few transistor is placed on single heat sink, like this. We have 3 transistors here, we place on single heat sink. Or we have an individual heat sink, which is 1 transistor will be attached on the single heat sink. So 1 transistor we have is individual heat sink. So it's always quoted that a semiconductor device is only as good as its heat exchanger. Why? Because if you use the transistor itself without heat sink, so you have to downgrade or degrade or reduce the current capability for that transistor for the usage without heat sink. But if you have a good heat exchanger, so you can use the device up to the maximum value that the device is stated to operate. So in power processor, in power processing system, the important term or the important characteristic of the power processor is that it should process or deliver or conduct or convey the power from input to output with the lowest loss possible. You can see here the total energy in, which is, if we consider as 100%, the energy out, if after we convert, maybe we reduce the voltage or increase the voltage. So we hope or we expect that the output, which is P equal to VI, the output energy or output power is at the highest possible. So it means that the wasted energy, which is converted into the heat, should be reduced as less as or as minimum as much as we can. So we can see that the P out divided by P in is the efficiency. So the lower the losses, so the better, the best the power converter is. So for example, we have here the example of lighting that we used previously, filament light. If we use filament light, we put, or it takes voltage and current from the lines. So we produce useful light, and we take 100 joules at the previous time when we use this kind of lighting. The useful light only consists of 20% of the what we put in. Another 80% is conduct or is already transfer or convert into heat, which is not in use at the time. That's why we change to fluorescent or recently to LED lights, which is from 100 joules of incoming, 90% convert into useful light, whereby only 10% and or transfer into or wasted into heat. So the efficiency, the percent of efficiency of ordinary light bulb is already overcome by changing the kind of application from filament into LED. So we can see here the Sankey diagram to show how the efficiency works, or the efficiency is represented. So in power electronics, the power loss we consider as all the losses is converted into heat, because we can measure the heat in terms of temperature rise. So this is what we're going to do, or we're going to experiment, or we're going to see in our power electronics application, or when we want to design our converters. So this is what we have to take into account, the temperature rise of our device or our semiconductor. Okay, when we want to design our system, we shall refer to design spec. Let's say we are going to select or to put our system or fabricate our system with a few selection of power device, rectifier, diode, thyristor, transistor, whatsoever. So this is the most important reference that we have to put into our technical design conception, which is manufacturer datasheet, MSDS. So each of device will come with their own datasheets. Maybe different kind of manufacturer, but they will produce their own datasheet. Maybe they have the same part number or reference number, same application, but the device itself, it will have their own limitation. So you have to take care on this kind of reference or this kind of consideration. So for this purpose, for this slide, please download and print out these 5 reference datasheet that we're going to use for the discussion throughout this subject.